students, I am back. So, we were discussing the chapter rotational motion, and now we are going to start the next module of the chapter rotational motion. This module is called as moment of inertia of a disk. Now students, in the last module also we discussed moment of inertia of a disk. Again, in this module also we are going to discuss moment of inertia of a disk, but here the axis of rotation, the position of the axis of rotation is different. Is that clear? So, interesting module again. Are you ready? Yes? Fine. Let us move on to the module. Now students, first we need to find out the moment of inertia of a thin disk about a tangent to its plane and parallel to the diameter of the disk. We have done this for ring already. Do you remember? Very good. Keep revising, then only you'll remember. Fine. So here first let me draw the diagram. I'm going to take a very thin disk. M is the mass of the disk and point O is the center of this disk. Alright? And R is the radius of this disk. Now students, first let me consider an axis. Now this axis ZZ dash is passing through the center of the disk and perpendicular to the plane of the disk. Is that clear? Fine. Next, I am going to consider another axis. Now this axis is passing through the diameter of the disk. Which axis? XX dash. XX dash is the axis passing through diameter of the disk. Now, if this disk rotates about the axis XX dash, then its moment of inertia is ID. Now, I have taken a point O. Now, why did I take a point O? See the title. We need to find out the moment of inertia of a disk about the tangent to its plane, and this tangent is parallel to the diameter of the disk. So I have taken a point O on the circumference of this disk, and let me draw a tangent through point O, but keep this in mind. This tangent is in the plane of the disk. Alright, so y dash is a tangent, it is parallel to x dash. So if this disk rotates about y dash, the axis y dash, then its moment of inertia is I naught. Now students, see the title. What we need to find out? We need to find out the moment of inertia of a disk about the tangent to its plane. So we need to find out what is I naught. So students, how will you calculate I naught? Yes. What is it? Two parallel axes. So which theorem? Very good. We can use parallel axis theorem. Now according to parallel axis theorem, I naught is IC plus MH square. Yes or no? So what is I naught? I naught is equal to, now what we can do here? We can write IC is equal to ID. Yes or no? See the diagram. IC is equal to ID. Alright. And we know the value of ID. Do you remember the value of ID? Yes. Last module we discussed. What is it? Yes. Very good. So you have revised. ID is 1 by 4 mr square. So instead of IC, I will write ID. ID is 1 by 4 mr square plus, hold on, we need to find out what is H. Now, if you see H is the distance between the two parallel axes, and here H is equal to R. So then I naught is 1 by 4 mr square plus mh square, H is equal to R. So it will be plus mr square. So now you can add it. 1 by 4 mr square plus mr square is 5 by 4 mr square. So I naught is 5 by 4 mr square. Now students, y dash is a tangent. So we can write I naught is equal to IT. Again, why IT? Just to signify that it is a tangent. So then we can write IT is nothing but it is 5 by 4 mr square. Isn't that simple? Again, we have used parallel axis theorem. Students, we have done this already for ring. Now here we are taking a disk. That's all. Is that clear? Fine. So can we move on to the next one? Okay. Now students, here we need to find out the moment of inertia of a thin disk about the tangent. Now this tangent is perpendicular to its plane. Again students, we have discussed this for a ring. Yes or no? No? Yes, we have discussed. You don't remember? Fine, no problem. First let us draw the diagram. I'm going to consider a disk. M is the mass of the disk and point O is the center of the disk. Again here, R is the radius of this disk. Now students, I'm going to consider an axis. Now this axis is passing through the center of the disk and it is perpendicular to the plane of the disk, ZZ dash. Is that clear? Fine. Now, if this disk rotates about this axis, then its moment of inertia is IC. Alright. Now students, see the title. Moment of inertia of a disk about the tangent perpendicular to its plane. So to draw a tangent, I'll take point O. Point O is on the circumference of the disc. And now let me draw a tangent through point O, but hold on. This tangent should be perpendicular to the plane of the disc. So x dash is a tangent which is perpendicular to the plane of the disc. Now students, if this disc rotates about x dash, then its moment of inertia is I naught. Now students, what do we need to calculate here exactly? Yes, we need to find out I naught. How will you find out I naught? Two parallel axes. So immediately it is parallel axis theorem. According to parallel axis theorem, I naught is IC plus MH square. So now you can write I naught is equal to IC plus, hold on, MH. H is the distance between the two parallel axes. Again see the diagram. H is nothing but it is equal to R. So I naught is IC plus MR square. Now students, what is I naught? We know I naught is IC plus MR square. We need to find out what is IC. Now we have already calculated, we know the formula for IC. Yes, in the last module we already discussed this. What is IC? Yes, can you remember? No, IC is nothing but it is half MR square. Yes or no? The last module. So then I naught can be written as half MR square plus MR square. You add them, what you'll get? You'll get 3 by 2 MR square. Now students, x dash is your tangent. So again you can write I naught is equal to IT. So then we have IT is equal to 3 by 2 MR square. Again a simple derivation students. It's all like that ring. Alright, same. Here it is just the disc. Is that clear? Any doubts in this? So students, here first we took a tangent in the plane. Second we took a tangent perpendicular to the plane. It is very simple. I am very sure you can do it. So students, I'll meet you up in the next module. Okay? Until then, keep working. Don't give up. I'll be back.